Okay, so let's take a look at how we solve this. So for the first one here, we have that x squared plus 2x is equal to 4. We want to make the left side equal to a perfect square trinomial. And again, a perfect square trinomial has the basic structure a plus b squared, which is equal to a squared plus 2ab plus b squared, which means that the middle term is double the product of the square root of the first term times the square root of the second term. So in other words, we want the 2x to be double the product of the square root of the x squared term and whatever the other term we're going to add in here. And in order to make that work, we need to add a 1 to both sides. And what we did was we took the coefficient 2, we took half of that, which was 1, and squared it, and that gave us the 1. And so then we added 1 to both sides, and we have to do the 1 over here. So now we can factor this left side to be x plus 1 squared is equal to 5, which means that x plus 1 is equal to the square root of 5, but it has to be either the positive or the negative square root of 5. And that means that x itself is equal to negative 1 plus the square root of 5, or negative 1 minus the square root of 5. And those would be our two solutions. And if we plug them in for x, it would make this equation true. We won't do that right now. Okay, the next one, we have x squared plus 6x equals negative 5. So to make this a perfect square trinomial, we have to take half of the coefficient of this middle term, which is 6, square it and add it to both sides, which gives us positive 9 equals negative 5 plus 9. On the left side, when factored, we get x plus 3 squared has to equal positive 4. So notice that we're actually getting a perfect square over here, and we'll see kind of what implications that has. Then we will take the square root of both sides, get x plus 3 on the left side is equal to positive or negative square root of 4, which means it's equal to the positive or negative 2. So we're going to get x plus 3 is equal to positive or negative 2, and that gives us that x is equal to negative 3 plus 2, or x is equal to negative 3 minus 2. This would give us x is equal to, first one gives us x is equal to negative 1. Second one gives us x is equal to negative 5. And if we plug either one in, you can see it'll make the equation work. So let's try negative 5. So we get negative 5 squared plus 6 times negative 5 is equal to negative 5. Gives us 25 minus 30 is equal to negative 5. Negative 5 equals negative 5, check. And if we plug in x equals negative 1, we see it'll also work. Okay, let's go to the next one here. X squared minus 5x equals 10. So now we have a negative middle term, and it's an odd number. So we're still going to take half the middle term and then square it and add that to both sides. So we'll get x squared minus 5x plus negative 5 over 2 squared is equal to 10 plus negative 5 over 2 squared. And on the left side, we can then factor that to be x minus 5 over 2, that quantity squared, is equal to 10 plus, and negative 5 over 2 squared is equal to 25 over 4, which means that the right side then becomes 40 over 4, which is 10 expressed as a fraction with a denominator of 4, plus 25 over 4 gives us 65 over 4. Okay, now we take the square root of both sides. We get x minus 5 halves is equal to positive or negative square root of 65 over 4. Which gives us x is equal to 5 halves plus or minus the square root of 65 over the square root of 4. And notice that I changed the form here, but these two forms are equivalent. And what the second form does is it allows us to say we can now represent this as x is equal to 5 over 2 plus root 65 over 2, or x is equal to 5 halves minus root 65 over 2. And again, that's because the root 4 can be expressed as 2, as we see in these two cases here. Okay, so those are our two solutions. Okay, next one. First step here is we want to deal with this 2, so we're just going to divide it out by dividing everything by 2 to give us x squared minus 4x plus 1 is equal to 5. For this left side to be a perfect square trinomial, this term here has to actually be equal to positive 4, so which is negative 4 divided by 2 squared. So we're going to therefore have to add 3 to both sides to get x squared minus 4x plus 1 plus 3 equals 5 plus 3. And then over here we'll get x squared minus 4x plus 4 is equal to 8. We can then rewrite this as x minus 2 squared equals 8. And then we can square root both sides to get x minus 2 is equal to the positive or negative square root of 8, which can be rewritten as the positive or negative square root of 4 times, or square root of 2 times square root of 4, which is then equal to plus or minus 2 root 2. So then we get x is equal to 2 plus 2 root 2, and x is equal to 2 minus root 2, 2 root 2 as our two solutions. Okay, let's go to the next page here and continue. All right, so we have 3x squared minus x minus 5. The numbers are getting a little uglier, but we can handle that. So first thing we'll do is divide through by 3 to get x squared minus 1/3 x minus 5/3 is equal to 0. And we'll move the constant term to the other side to get x squared minus 1/3 x is equal to 5/3. So now we have to take half this x coefficient, square it, and add that to both sides. So that'll give us x squared minus 1/3 x plus 1/6, which is half of negative 1/3, or really negative 1/6, squared is equal to 5/3 plus negative 1/6 squared. Okay, when we factor on the left side, we're going to get x minus 1/6 squared. And on the right side, we'll get 5/3 plus 1/36, which we're going to say is equal to, we now want to make 5/3 as a fraction with a denominator of 36, so we'll multiply top and bottom by 12 to get 60/36, equivalent to 5/3, plus 1/36 is equal to 61/36. All right, now we'll square root both sides to get x minus 1/6 is equal to the square root of 61/36, which you can rewrite as root 61/6. And so, and that again will be positive or negative, positive or negative. So we'll get x is equal to 1/6 plus root 61/6, and x equals 1/6 minus root 61/6. Okay, so let's take a look now at our last problem here, which is an application problem. And we have the height of a ball or an object off the ground when thrown into the air from the top of a particular building is given by this equation here. negative 4.9 t squared plus 49t plus 245. T represents the number of seconds since the object was thrown. H is the height in meters of the object off the ground. Okay, so a couple things about this. This 49, by the way, represents the initial velocity of the object at time t equals 0 in meters per second. This 245 represents the height of the object off the ground at t equals 0, or 245 meters. The negative 4.9 is basically a result of the gravitational constant here on planet Earth, and because this term represents the force of gravity, which is pulling the object to Earth, and the negative 4.9 would be a coefficient that would vary depending on what planet you are on. On planet Earth, it's negative 4.9. Okay, how high is the object 3 seconds after being thrown? We just plug in 3. So we get negative 4.9 times 3 squared plus 49 times 3 plus 245 as the height of the object. So we'll get negative 4.9 times 9 plus 3 times 49, which is 147, plus 245. And this will give us negative 44.1 plus the sum of these two, which is 392. And so in the end, we'll get a positive 347.9 meters off the ground at time t is equal to 3. Okay, now this is asking us, when will the object hit the ground? So we want to work this by setting the height equal to 0, because that's when the object's on the ground, the height is equal to 0. So we would now solve using completing the square, and so we'll have negative 4.9 t squared plus 49 t plus 245 is equal to 0. So the first thing we'll do, as we've done before, is divide through by this coefficient, which will give us t squared, and then 49 divided by negative 4.9 gives us negative 10, and 245 divided by negative 4.9 gives us negative 50, and this is all equal to 0. Okay, so now we'll move the constant to the right side. T squared minus 10t is equal to 50. And then we'll add to the left side the value, actually to both sides, the value we need to make this a perfect square trinomial. So we take half of negative 10 and we square it. So that'll give us a positive 25 here equals 50 plus 25 over here. Now we factor this to get t minus 5 squared is equal to 75. Okay, take the square root of both sides, get t minus 5 is equal to the positive or negative square root of 75, which can be rewritten as the square root of 25, positive negative, times the square root of 3. And so t minus 5 is equal to, or I should say t is equal to 5 plus or minus 5 root 3. So 5 minus 5 root 3 is a negative number and does not make physical sense in this problem. So we're left with t is equal to 5 plus 5 root 3. And because we're dealing with a real world problem here, we're not going to leave it with the square root. We want to get a number that, you know, people can sort of get a better sense of. So we get t is equal to 5 plus 5 root 3 is about 8.66. So we end up with t is equal to 13.66 approximately. And that means that the object will hit the ground about 13.66 seconds after it's been thrown into the air. And graphically, what that would mean is that we would have something like this. Sorry about that. And this would be at, let's say, 13.66. And we might say the initial height of the object was 245 meters. And let's say at about 3 seconds, it was up at, we said about 347 meters. And so it looks sort of like this. Up, 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 reaches a peak, comes down, hits the ground here. This is terrible drawing, but we would reach our peak somewhere up around here. Notice that this part of our figure is all with a negative t value, so it doesn't make physical sense, but this would be the other value we got up here when we have 5 minus 5 root 3. That would give us whatever this value is here. Okay, but this is our solution, 13.66, 5 plus 5 root 3.